fluid mechanics, manometry, pressure measurement, Pascal's law. The intensity of pressure at any point in a stationary fluid is same in all directions. Mathematically, this isotropic distribution of fluid pressure is represented as Px equal to Py equal to Pz. Pressure vary only with depth in stationary fluids. However, if the fluid is in motion, pressure may vary in the horizontal direction as well. Fluid pressure is measured in units of force per unit area and is standardly expressed in pascals, Newton per meter square or bar. Fundamental unit conversion 1 bar 10 to the 5 Newton per meter square, 1 megapascal 10 bar, 1 kg 9.81 Newton. A barometer is used to show and measure ambient local atmospheric pressure. Pressure is a scalar quantity because it possesses magnitude, but its operation at a point is isotropic, equal in all directions. Absolute pressure. Pressure measured with reference to absolute vacuum, absolute zero pressure reference. Absolute pressure cannot be negative. P absolute is equal to P gauge plus P local atmospheric. Gauge pressure. Pressure measured with reference to the local atmospheric pressure line. It can be positive. Above the atmosphere negative, below the atmosphere known as vacuum or zero. P gauge is equal to rho GH. Rho density of fluid, G acceleration due to gravity, H fluid height, pressure head. Relation between absolute gauge and vacuum pressures. P gauge positive. Local atmospheric pressure line PATM 1.013 bar. P absolute greater than PATM. Absolute zero reference line. Complete vacuum. Vacuum gauge. Atmosphere pressure vary dynamically with altitude, local temperature, environmental weather conditions. At mean sea level, standard atmospheric pressure is equal to 1.013 into 10 pascals or 1.013 bar, 10.3 meters of water column square, 76 centimeters, 760 mm of mercury, column heads, fluid mechanics and fluid machines. Hydrostatic laws. The hydrostatic law states that the rate of increase of pressure in a vertical downward direction must be equal to the specific weight of the fluid at that point. For downward direction, S measures downward dp by ds is equal to omega is equal to rho g atmospheric surface. For upward direction, S measure upwards dp by ds minus omega minus rho g, where omega represents the specific weight density of the fluid. Conversion of one fluid column to another fluid column. To find the equivalent column height of different fluids acting under the same pressure intensity, the column heads are converted using their respective mass or relative densities. The rho 1 H1 is equal to rho 2 H2. S1 H1 is equal to S2 H2. We can write rho mass density of the fluid or S specific gravity relative density of the fluid. Pressure measurement device. Piezometer are structurally limited to measuring very small positive gauge pressure. They cannot measure negative vacuum pressure or highly evaluated gaseous heads. A simple U-tube manometer provides the utility to measure both positive and negative gauge fluid boundaries safely. Manometry liquids. Manometric liquids must possess a high mass density to prevent long on manageable column loop and low vapor pressure to suppress errors induced by boiling or cavitation within the tube. Barometer, aneroid or mercury barometer evaluates the ambient localized atmospheric threshold on an absolute datum plane. Standard reference values density of mercury 13.6 into 10 to the 3 kg per meter cube, density of ambient air 1.24 kg per meter cube.